I'm here today with Keith Shepard. Keith devoted his career to making soil knowledge fast, affordable, and useful for real-life decisions. At World Agroforestry and later as chief scientist at ISDA, he championed infrared spectroscopy. What is it? Basically shining light on soil to read its chemical fingerprint. So agronomists and farmers can diagnose fertility and other properties in minutes instead of weeks. He helped build reference labs and global spectral libraries so the method works consistently across regions, turning a scientific tool into a very practical service for agriculture. He also developed the Land Degradation Surveillance Framework, LDSF. In short, Keith's lifetime work connects quick, reliable diagnostics with better decisions for farmers and for policymakers. So Keith, let's get started. You have worked internationally in agriculture. Looking back, what were the main challenges then, and how do you look at the main challenges today?
Well, I think some of the main challenges really haven't changed much in that, it was all about increasing crop production to meet food security needs. I think the big change has happened because we're much more aware of environmental factors now. So, in the north, the emphasis now is on decreasing nutrient inputs to reduce pollution, whereas in Africa we're still at the stage where there's enormous need for investment in soil fertility, and that actually, the low soil fertility is actually producing more environmental damage than anything else, because with low crop cover, the soil is exposed to rain, the soil's eroding into causing a lot of off-site damage, economic damage, silting of rivers, dams, and depleting the soils further. The need there is to really increase nutrient inputs to reduce environmental damage. And that's not always widely appreciated. So I think, and then the big thing that I think isn't recognized is that increasing productivity on farms is the key to reducing greenhouse gas emissions by reducing off-site deforestation and loss of biodiversity. That's the big one, is the greenhouse gas emissions and deforestation. So increasing productivity on farmland, on cropland, is the key to reducing environmental damage, actually. Yeah.
This is really interesting, because what I'm hearing you say is that things have changed, but things haven't changed that much or not enough, especially in some parts of the world like Africa. So let's go to the core of your work. If I were to hand you a scoop of soil here on camera, what can your spectrometers tell us in 60 seconds? Like, what will we see that is so different and so new in your work?
Yeah. Well, I think the key thing is that, within seconds we can scan a soil, collect the reflected light coming back off the soil in different wavelength bands, and that spectral signature or pattern we get off the soil contains a lot of powerful information, since we can relate many other soil properties that we conventionally measure in the laboratory using time-consuming methods to those spectral signatures. So within seconds we can get a profile of the soil properties, or many of them.
And so do we then find out what the soil needs, like what nutrients we have to add and how we need to work with the soil?
That's part of it, but I think the key value of it is that we're able to analyze many more soil samples than we could ever afford to do. When we started the Africa Soil Information Service, we collected like 10,000 soil samples from over Africa. And how are we going to analyze those through conventional means? And so this is where we brought in the soil spectroscopy. We could scan those quickly and cheaply and then calibrate the soil properties to those. And the most powerful thing that led to actually was being able to produce a digital soil properties map of Africa, because now we had lots of georeferenced estimates of soil properties from thousands of locations across Africa. We can calibrate that back up to remote sensing imagery and then map out those soil properties across the continent. And then, farmers standing in a field can now download that information and go into an advisory system. Governments can use that information to target where in the country they should be targeting lime or different fertilizers.
With the development of AI, how can that be a scale up for all the work that you have done on soil? Because I can imagine that there is probably some knowledge sitting in the artificial intelligence systems that could feed off the data that you have collected through soil sampling.
Yeah, well, the power of AI is sort of recognizing patterns, and that's where, finding the patterns between our ground observations and all these remote sensing layers, that comes in. But still the limiting factor is the number of ground observation points that you can train with, and that's where the spectroscopy comes in, because it just allows you to sample so much more densely and analyze the soils than you would ever imagine.
And you do it faster and cheaper, I suppose.
Exactly, yeah.
Okay, so you have looked at a lot of soils around the world, I guess mainly in Africa, but around the world. So what are the most shocking soil truth, if you were to put it this way? Something that you didn't expect, something that farmers didn't expect, and something that the governments perhaps didn't expect.
I don't think it's so much, discovering something that wasn't known about soils, but I think the big discovery was that you can, with this technology, produce maps at different scales that can be used to make decisions. So, a farmer in the north in high production agriculture could be making a digital map of their field for targeting their fertilizers within that field, for example, at that scale.
Is this basically leading us closer to what we call precision agriculture?
It is, and I call it, in Africa, I call it precision agriculture for smallholders, because we're able to now provide advice, down to an individual plot level, to an individual farmer. And that is very powerful now, yes.
Right, so you must have seen some amazing impact on yields in some cases. Give us a few examples where yield actually increased fundamentally to change the situation of that particular farmer.
Yeah, well, through the digital advisory services we're providing at the moment, we're seeing yield increases of on average one and a half times in the first season. So the idea is to sort of build up the skill of the farmer and the yields over time, from a low base, and season on season start to improve their yields and their profitability. I mean, the key limit to profitable agriculture for smallholders in Africa at the moment is the low baseline soil fertility. If you have a farmer in the US and they don't apply fertilizer, they'll get about 5 tons per hectare of maize. But a farmer in Africa will only get half a ton of maize per hectare if they don't apply.
Because there's nothing in the soil.
And they can't make any money, whereas the US farmer would still be making money even at those yields. So that is the critical thing to increasing profitability for farmers, is to raise up the baseline fertility by systematic improvement in the soil fertility levels.
So the number that I'm taking away from this part of the conversation is 1.5 times. 1.5 times yield just by doing a little bit of work.
That's on average. I mean, when farmers really put in all the recommendations, they can get 2 or 3 times, the yields. Yeah.
So what would it take to get us to scale it?
Well, in ISDA, if I may, we're working with the Virtual Agronomist as our main tool, which is a digital agriculture advisory system that's delivered through WhatsApp. So most farmers, we found, are using WhatsApp to talk, with each other. And we've launched our platform through WhatsApp. So basically all the farmer needs to do is dial a number in a country, will be registered in, and then they can walk their plot there where they want to grow crop, the corners, and those are geo-referenced using WhatsApp. And then we show them a map of the plot on a satellite image and say, look, does that look right? And this is the area of your plot, which many farmers don't actually know. And then we provide a balanced nutrient management plan for them by asking them various questions about the soil and crop management history. We download the soil properties from the ISDA soil map, which we've produced, that came out of the Africa Soil Information Service, which shows the farmers the nutrient levels in their soils, which they're very keen on. And from that, we provide a sort of tailored nutrient plan they can use. It takes them through all the decisions in the cropping season, so that, gets them to check their crop emergence, if there are problems with that, to help to diagnose it. It takes them through to plant health, plant disease and pest scouting, how they can manage those through the top dressing advisory through the harvest advice. So they get all that advice through the season and how to make best use of the fertilizer that they are applying, make sure they get the returns on the expensive fertilizer inputs they're getting.
Listen, I can easily see scalability in it, because that is how you scale it.
So we've in 18 months got up to now about 400,000 100,000 farm plots across several African countries, and in one Kenya county we've penetrated 80% of the maize farmers, so we can really get very fast penetration to farmers through this tool.
Excellent. So let us shift gears a little bit. I would love to hear more about the land degradation surveillance framework. Tell us a bit about it, how it got developed, and what can we learn from it?
Yeah, we actually borrowed the concepts from public health surveillance in the sense that, we wanted to sample populations of soils or land. So we had this vision to sample the whole of Africa, basically, which was very ambitious. So we laid down the first sort of statistical sampling frame of African soils and land with a protocol that we worked on that was standardized. And we applied that, all over Africa, and that led to the actual, it's the soil, the digital soil properties map of Africa came out of that. But it also led to, some other surprises in the sense that, we had one area in Kenya, for example, on the shores of Lake Victoria, where there was a lot of soil erosion coming into the lake, and all the soil conservation efforts had been up in the highlands, in the sloping lands, where the assumption was that, the soil erosion into the lake was all coming from that area.
Right.
When we applied our systematic land, health surveillance, we found actually that nearly all of the soil was coming from the lake plains and almost flat land, which, any erosion prediction model will tell you no slope, no erosion. And it was very fragile lake deposits, and there was a huge gully erosion system there going into the lake, which really hadn't had any attention paid to it before. And we were able to show that, the soil conservation efforts were being put entirely the wrong place.
Yeah, so it's completely shifted how you actually addressed it, I suppose. That's great. So we're going to shift gears again, and everyone's talking about carbon.
Right.
And everyone's talking about how farmers can really help solve the equation with carbon. But we also know that there are many issues around soil carbon credits. So tell us, what is the fix? How can we actually deal with soil carbon that actually benefits the farmer, that actually rewards farmer for good nutrient management, for good care of their soil? Because we know they care.
Well, I don't think for smallholders in Africa, carbon credits is the answer, because simply there are biophysical limits to the amount of crop residues and organic inputs going back into the soil. So, at an individual farmer level, they wouldn't be able to make more than $1 or two per hectare per year from carbon credits.
So that's not really an avenue.
But it could work if it was done at a large watershed scale, where you were trying to put in a conservation scheme at that level and manage the thing at that level, I think. But the big issue is the off-site losses from deforestation. So by improving on-farm productivity, we can reduce the loss of the greenhouse gas emissions from off-site, and I think that's the key thing. So focusing on soil improvement, on productivity improvements on farm is key to managing
to save carbon somewhere else and not convert
the greenhouse gas problem, I think.
Right.
Yeah.
So we touched upon AI a little bit, but I would like to take us to the future, where every farmer has a pocket soil scanner and is linked through smartphone to an AI system, to ChatGPT or whatever else. What, in your view, will become obsolete in terms of jobs or occupations, and what are the new jobs or businesses that may appear overnight, if that would be the future?
Yeah. Well, I think many years ago, I had the vision of having a handheld, spectrometer that was cheap enough for farmers to have in their hand, and I've helped design those and so on. But looking back now, I don't think that's really the answer. I think the answer comes from applying that technology by getting many sample points across Africa or across the country, and then using that to generate these digital soil maps, which then can provide accurate information from anyone, anywhere, for any purpose. So I think perhaps in some settings in more advanced agriculture, that might have an impact into a farmer having something in his hand going around a field, But even then, probably he wants to bring it back to some sort of mapping product at the end of the day. So I think probably the new businesses will be generating these digital soil maps at different scales, from individual farms up to national level. I think that's where the sort of action will be.
Interesting. if you could have a message for agriculture ministers on the continent or elsewhere, what are some of the key messages that you would want them to have from you, from your work on soil mapping, from your work on getting this information to the farmers fast and efficiently?
Yeah, well, I think that the need for nutrient inputs into soils, and it has to be fertilizer in Africa because there isn't simply enough organic material. I mean, it's always best to combine both organic, inputs, manures and fertilizer, but there isn't a sufficient organic manure to do that by itself. So there has to be, like in every other country in the world, there has to be decades of input from fertilizers in a judicious way to build up soil fertility. But to do that needs a whole lot of supporting, activities. You need the infrastructure to be able to, import and distribute or manufacture within countries the fertilizers. You need the warehousing to, house it and distribute it. You need the distribution systems. You need the digital advisory systems like we're working with with Virtual Agronomist to get the right advice together with the inputs out there. So, that investment is imperative because, we're so off reaching even the basic minimum feed security, never mind for becoming an exporter to other countries.
So my very last question is the following. You are the recipient of a very prestigious IFA prize, and we are really grateful for your lifetime work in this space. What would be a recommendation for IFA or others to bring the work of scientists much more into public domain? We find that you do some amazing work and a lot of people do not know about it. We have so much misperception, miscommunication around soil, around fertilizers, around plant nutrition writ large.
Well, I think things like this prize, I hope, will help. To bring attention to the needs, and but I think we just need to keep singing the right messages in the right places consistently, and I think that's the key, really. Yeah.
Excellent. Well, thank you very much for joining us today. Once again, congratulations. But even more importantly, thank you for your lifetime work in this space. It's very impressive what you have done, what you have achieved, and most importantly, how we can scale it up for the impact on the continent.
Well, I'm deeply honored to have received the prize, and thank you.
Thank you.